MAGECK is an algorithm that analyzes raw FASTQ files from CRISPR-Cas9 screens considering multiple conditions and identifies essential genes. VISPR is a web-based front-end that lets users interactively explore results and quality-controlled data. The two are seamlessly combined in MAGECK-VISPR, a comprehensive quality control, analysis, and visualization workflow for CRISPR-Cas9 screens. In the previous video, we showed you how to download and set up the workflow. In this video, we'll demonstrate how the process works from inputting raw data to configuring the workflow to getting to VISPR's visualizations. We again recommend that you follow along and complete each step as it is being shown in the video. Since the process is slightly complex, we also recommend that you follow the demo exactly the first time you watch and adapt it to your own needs later. The first step is choosing the directory where you'd like MAGECK-VISPR to be executed and results to be stored. This should be an empty, meaningfully named directory. To this end, we'll create a directory named esc-test in Downloads. Next, you'll need to organize your input files. When you run the workflow with real data, these will be your raw FASTQ files in CSV sample library. To get the example files for this tutorial, visit the MAGECK-VISPR manual at bitbucket.org/leolab/MAGECK-VISPR. This page contains all of the steps for usage of the workflow, and you can refer back to it at any point during the tutorial. For now, scroll down to the section titled Testing MAG and download the dataset provided for configuring the workflow from scratch. Though the input files can be located anywhere, it will make things easier later on if you extract them into the directory chosen in the previous step. Issue tar xpfj in the directory followed by the file path to the zipped data. The newly extracted esc-testdata directory contains three things: the library, a reads folder containing the FASTQ files, and a design matrix. This last file is an optional addition that we will explain later. Now, it's time to initialize the workflow. Issue MAGECK-VISPR init, followed by the path to the workflow directory. Since we're already there, we can use a dot to signify the current directory. Then, enter --reads followed by the paths to your samples. You can do this by manually typing each path, dragging files into the terminal window, or using an asterisk to signify a wildcard. This command will create a README, a configuration file, and a Snakemake workflow definition in the workflow directory. Advanced users can choose to adapt the snake file to their own needs. To learn more about Snakemake, visit the link to the documentation in the video description below. You will now begin the process of configuring the workflow to your needs. To do so, you'll have to open up the configuration file with your preferred text editor. First, enter the path to the library for your sample sgRNAs. Throughout, file paths should be relative to the location of the configuration file. Specify the species and assembly used in your experiment for proper labeling in VISPR. The tutorial dataset is from an experiment on mouse embryonic stem cells, so we will label it accordingly. If your targets are genes, leave the next entry as true so that VISPR can properly incorporate gene exploration features like ensemble and gene mania. If your data includes a control file, uncomment the next section and enter the file path. Next, adjust your sgRNAs as necessary. Enter the number of nucleotides to trim from the 5' end and the length of the sgRNA. If there's an adaptor sequence that needs to be removed from the reads, you can specify the sequence. The example data doesn't need this adjustment, so we'll leave that commented as well. If you provided FASTQ files to the workflow earlier, you'll see that the file already contains the paths as well as suggested sample names. Edit these by renaming samples and grouping replicates as necessary. In the tutorial data, we have one control and two treatment samples with a single replicate for each. The last part of configuration is defining experiments for use with MAGECK. One way to do this is by providing treatment and control samples for analysis with the previous version of MAGECK, MAGECK-RRA. If you have samples under several different conditions, you can also choose to provide a design matrix for analysis with the new MAGECK-MLE method. We'll demonstrate the new method in this tutorial. The text file entered here should contain a matrix with sample names as row headers and experiment names as column headers, with the body filled with zeros and ones indicating absence or presence of the sample in that experiment. MAGECK requires a baseline column of all ones for all samples, and the rest can be customized by the user. For more information on the design matrix, visit the MAGECK documentation linked in the video description. Back in the configuration file, check that the file path to the matrix is correct. Unless you're using both methods for experiment definition, make sure to comment or delete the unused one. The name you enter for your experiment will appear in VISPR, so choose a meaningful one like ESC-MLE. We have finally finished configuration and are now ready to execute the workflow. Save and exit the configuration file. Back in the workflow directory, first issue snakemake-n to test that the configuration file has been properly constructed. If there are no configuration errors, a list of the jobs about to be executed will be returned. Proceed with snakemake to begin the actual execution of the workflow. By default, the workflow uses one CPU core. To increase this, append ---- cores and the number of cores you wish to use in parallel. Using a terminal command, you can monitor the log files shown after each step. Issue tail-f followed by the file path of the log file to get live progress updates. Once execution is complete, you can take the final step by issuing vispr server results /*.vispr.yaml in the workflow directory. A link will be returned. Paste this into a web browser to access the VISPR home screen. Click on the first tab to select the experiment you wish to view, and peruse the next 3 pages for results and quality control visualizations. For more information, watch the next videos on how to use VISPR. You now know how to harness the MAGECK-VISPR workflow to turn raw CRISPR-Cas9 screening data into interactive visualizations of results and quality control data. For more information on MAGECK-VISPR, Snakemake, design matrices, or anything else in this video, please visit the links in the video description below.